Hi there. This is a quick review of how to graph linear inequalities. We have talked about, we've been doing graphing equations or graphing lines for quite a while. So it's the graphing of the lines that's not the really challenge here. It's how do we indicate a solution in a linear inequality. The linear inequality has something called a solution region. So we need to be able to indicate where on a graph, I'm going to do a really rough sketch here, where on a graph of an inequality is the solution located. So what we'll find is that we will graph, some line, and then we're going to have to indicate somewhere on the graph where solutions to this inequality are located. So there's a lot of times we refer to it as shading, right? We need to shade or indicate where the solutions are for graphing a linear inequality. So let's take a look at some simple examples about linear inequalities. First and foremost, what we do need to talk about is the lines themselves, sometimes referred to as a boundary line. If the inequality is either less than or greater than, we use a dashed line. If it is less than or equal to or greater than or equal to, we use a solid line when we graph. So we need to keep that in mind as well when we start doing these equations. So linear inequalities can look something like this, like y is greater than 3x plus 2, or it can look at like something like 3x plus 4y is less than or equal to 8. These are two examples of what a linear inequality will look like. So let's take a look here. So suppose we're given the linear inequality y is less than or equal to 3/4 x plus 1. First thing that we notice is this symbol here. So this will be a solid line or a solid boundary line. We notice also that the slope for this linear equation is 3/4 and that the y-intercept is equal to 1. So the way we handle this is we first graph the line. And then second, we're going to test a point. We'll look at that in just a minute. So let's first graph a line. So let me see if I can draw a fairly good XY axis here. And this is not too bad. Right? So what we're going to do first is we're going to graph this inequality as though it were just a linear equation. So we're going to graph the line y is equal to 3/4 x plus 1. So that means we go to 1, 2, 3, 4, 5, 6, 7. Let's draw some lines here. Make this look like a coordinate plane here. So we're going to start by plotting a point at y is equal to 1, and then we're going to go up 1, 2, 3, and then over 1, 2, 3, 4, and that would be our second point. And then, since the line is solid, I'm going to graph a solid line that goes through those 2 points. So there's graphing the line. The next thing that we need to do is we need to test a point. And what that means is that we're going to choose a point somewhere on this coordinate plane, and we're going to plug the information about x and y into our inequality and see if we get a statement that's true or false. The easiest point that we can test is probably 0, 0. So we're going to test the point 0, 0. Now you can pick any point you want. You have to pick a point, though, that is not on the line. 0, 0 is not a point that is on this line, so we can use 0, 0. So I'm going to put 0 for x and 0 for y. Remember, these are ordered pairs, right? So in the original inequality, in this inequality here, I'm going to plug in the point 0, 0. So when I do that, I put 0 for y is less than or equal to 3/4 times 0 plus 1. And if I solve this, or simplify it anyway, I get 0 is less than or equal to 1. And that's true. So what that means is that this point 0, 0, the origin, is also true. And that means that every single point on this side of this line is a solution to this inequality. This is the solution region. So we test a point, we see if it's true. If it's true, we shade on the side that's true. If it's false, we shade on the other side of the line because that one will be true. So let's take a look at another example. Again, I'll use something in y equals mx plus b form, like y is greater than 2x minus 4. So first we'll graph the line. Oops, let me erase that here real quick. Graph the line. Y equals 2x minus 4. Now we look at that inequality symbol. This is going to be a dashed line. So first we'll graph the line. So let's see if I can repeat what I did before and draw a pretty good XY axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're going to start at y is equal to -4, which is right here. And then we're going to follow this slope of up to 1, 2 over 1, up 2 over 1. And then we're going to draw, and hopefully I'm going to do this fairly straight, we're going to draw a dashed line that goes through those points. So there's our line. Step number 2 is we're going to test a point. Again, since 0, 0 isn't on our line, 0, 0 would be a great point to test. So let's test the point 0, 0. So I'm going to plug in 0 for x and y into the original inequality. 0 is greater than 2 times 0 minus 4. 0 is greater than -4, which is true. So that means that point is true. And that means every ordered pair on this side of the line is true. This is our solution region here. Okay, now I draw arrows. You can shade, actually take your pencils and shade. You can do that. Let's look at another example here. Suppose we are given an equation that's in standard form, a linear inequality that's in standard form, such as x plus 2y is greater than 4. First, we need to graph the line. So first we need to take x plus 2y is equal to 4 and put it into slope-intercept form. So we could subtract x from both sides. And then we could divide both sides by 2. And we get the linear equation y is equal to 2 minus x over 2. That means our slope is equal to -1/2. And that means our y-intercept is equal to 2. So if we graph that, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. That means that we would start our graph at y equals 2, and then we would go down 1 and over 2, down 1 and over 2, and because this is greater than, we're going to use a dashed line, right? And we'll see if I can do that. So it should look something like this. Step 2, test a point. So we'll use 0, 0 again. So we'll use 0, 0, and we plug 0, 0 into the original inequality. 0 plus 2 times 0 is greater than 4. So we get 0 is greater than 4. And that's not true. That is false. So that means that the origin in this situation is a false point. Since that's the case, we are going to shade on the other side of this line. Okay, so we only shade on the side of the line that's true. And in this situation, since 0, 0 is false, the other side of the line is the true side. Let's see. Another example. Let's look at another example. How about how about y is less than or equal to 3x? So first, graph the line. And what you should see here, right, is that we're going to graph the line y is equal to 3x. The slope here is 3 over 1. The y-intercept is 0. So let's graph this line here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So when we graph this, right, we start at the origin, we put a point at the origin, and then we go up 3 and over 1. And this is going to be a solid line, right, because this has got an equal to. So our line will look something like this. Now, step 2 is we want to test a point. Now, the problem here is that 0, 0 is actually a point on our line. So we need to test a point that is not on the line. You have an infinite number of options, but your best options are probably on the axes. So let's take the point 2, 0. So this is the point 2, 0. We're going to take 2, 0, and we're going to plug it into our inequality. So I'm going to put 0 for y, I'm going to put 2 for x. 0 is less than or equal to 3 times 2. 0 is less than or equal to 6, which is true. So that means that this point is also true. And that means that this side of the line is where our solution region is. So we shade on this side of the line. Last but not least, let's take a look at an example of a horizontal or vertical line. So let's say we look at the linear inequality y is greater than or equal to 2. So first, we want to graph y equals 2. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So graphing this is a horizontal line because it's in the form y is equal to c. So we're going to draw a horizontal line here. And it's solid because of this, right? So we know it's going to be a solid line. Next we could test a point, but we can also just think about it. We want y values that are greater than or equal to 2. Y values that are greater than or equal to 2 are up here. But if we tested the point, let's test the point 0, 0 just to confirm that. I put 0 for y. 0 is greater than or equal to 2, which is false. So this point would be false. But again, if we think about it, we want y values that are greater than 2. Well, those y values are up here above the line, right? So we can also do inequalities for vertical and horizontal lines. So I'm going to end this video. It was a little bit longer than I expected, but this is a quick review of how to graph linear inequalities.